Hello YouTube, my name's Dave. Welcome to my workshop in a single car garage here in South Australia. Come on in and let's see what we can make. Hello again and welcome. And in today's video I shall be demonstrating a nice simple block milling exercise. Now I'd like to point out that the actual machining that you'll see wasn't my idea. I see somebody else do it on YouTube. I think it was probably something like, I don't know, may have been Joe Prinski, I'm not sure anyway. But as I say, you know, a good idea needs the word spread, so that is what I'll do. So we'll now adjourn outside to the milling machine and let's get on with it. See you at the milling machine. Bye. So what you're seeing here is a typical setup for machining a part. Now I'll try and actually be machining this bit. I'll just use it for illustration and show you the number of operations that you need to do it. I mean, say you want just a spacer to a packing bar to standard engineering tolerances, you know, plus or minus 5 thou. So you find yourself a piece of stock. So first off you've got to measure what size it is to know how much to take off. Now assuming that we only want two sides can be stock material, so first off you've got to measure it up to find out how much to take off. So obviously you put it in there, you touch up on the top, skim it off, take it out, rotate it through 90 degrees, do the same operation on there. Then what you need to do, of course, is to machine the ends. So you know, you stick it out, you machine the end. You then got to flip it end to end. Take no notice, it's got a thread on it. So you then machine the other end, and then you've got to measure it. So what have we ended up there? So to do that, you've had 2 rotations, 2 end flips, and 2 measurements to get the size. So what you say? I mean, yes, I've done it in the past and probably have to do it again, but I'm now going to show you a much simpler and quicker way of doing it, and you won't need any measuring tools. So what I have here is just an aluminium block, and eventually I shall want 1.5 by 3/4 by 500 thou thick. Now you can also use, if you've got sufficient to get it out there, you can use a piece of round bar, as long as you can actually get you know, when you've actually milled a flat across the top that's wider than what you want, and you've got enough depth, you can use it. You can use a round bar for this. You can put it in there, and I'll now show you how to machine the feature. But I'll use the aluminium block. So first off, what you need to do is to shove it in there. And it doesn't really matter whether your vise is even trammed in or not, because what we're actually going to be doing is you'll be using the machine slides, the X, Y, and the Z, to give you the features. So what we need to do is to get in, Davey. Trouble with these quick release jaws. Right, so there we are. Sorry about that. I would say it's pilot training again, going around the you know, the bumps and circuits. So I live right there at a local airport. So right, so there we are. That's it, nicely tightened up. Now the only you can actually, what I'm going to do now is you can do it on a machine whether you've got a DRO or not. If you haven't got a DRO, you must take into consideration any backlash that you've got on your lead screw and nuts. And the only thing that so that there's going to be no measuring instruments involved in this. The only thing that I have measured is the cutter, because as I say, you may be lucky enough that you've got you know, your cutters you know, you've had from you, they've never been sharpened, so you know, you bought it as a 1/2 inch cutter and it should still be 1/2 inch. These cutters are probably at least 50 years old. Some of them of what I've acquired from work, and some are what my father's were. Now this is a 7/16 one that's been reground, and it's only 0.432 instead of 4375. So that's what you need to, that's all you now need to know is and most important is what the diameter of this cutter is. Right, so first off, the first thing we need to do is to clear the top surface, any amount you like. So we've got plenty of stock here, so we'll take a little skim off the top. Now I've blocked my quill. I've set the knee to 0, and I've set my DRO to 0. So we'll now take a little cut across the top. The brake off, yeah, the brake is off, and away we go. Right, so there we are, that's the top surface done. If you're happy with it, it's cleaned up, and that's it. That's all we need to do. Right, switch that off. Now what you need to do is to raise the knee, or if you can't and you've got to lower your quill down, you want to take it down about 20 thou more than what your part wants to finish in thickness. Now in my case, it's I want it to be 500, so I'm now going to raise my knee 520 thou. Nearly there. There we are, that's near enough. Right, 521. Not important, because that will be sorted out in the end. Right, now the next thing we need to do is notice I say no measuring tools at all. Right, next thing we need to do is to and I should be working in a clockwise direction. So what I'll do is we'll start up and we'll take a skim along the back until it cleans up. We've got plenty left on here, so it doesn't matter how much you take off. So we'll take a skim along the back. Now, as I say, I'm fly milling, but you can or not, it's up to you. Just depends on how much your backlash of your machine is. Right. So that's the back face cleaned up now. Right, what you need to do now is to zero out your Y, or if you're working on a manual machine, zero out your Y cross dial. Right, now here's where the clever part comes in. Bearing in mind that, say, working in a clockwise direction, we need to take cuts until that reaches the dimension we need. Now I actually require this to be 750 thick. So to work that out now is we're doing this just by the dials and the DRO. So what we need to do now is to move the y-axis 750 plus whatever diameter that cutter is, and mine happens to be 432. So I've now got to start machining on this side until the dials in the clockwise direction reads 1.182, or I'll do it on the DRO. So it's one on the other end. That's the trouble working here, trying to work around the camera. Log juice, that's kerosene or paraffin as it's known in England. Fly milling, so this machine can take fly milling, no problem at all. Get in there, 1.182. 230, so keep an eye on what you're doing. So about 50,000 to go. Six, so we want 1, 2, 185, and what I'll do is I'll bring it back as a flying cut. So get a better finish that way. Now bearing in mind, so if you're doing this with working with the dials manually, take into account backlash. So before the final cut, withdraw it back towards you and then advance in a clockwise direction until it reads whatever dimension you want. In my case it's 182, which is there, right. Right, so that is that bit done. Right, now the next thing to do is to clean up one end. That's cleaned up nicely. I'm now happy with that. Right, so what you need to do now is to zero your X-axis dial if you're doing this mechanically, or if you've got your DRO, you zero your X DRO. Now we need to, I want this part to be 1.5 inches long. So what we've got to do now is to keep milling this end, taking into account the diameter of the cutter. So it's 1.5 plus 0.432 for the cutter. So the final size on the readout or your dials are going to be 1.932. So we'll crank that along now. Quite a bit to come up here at the moment, so what I'll do is I will stop the camera for a minute and I'll bring you back when I'm on the final. So here we are, we're almost down to size now. As I say, must bear in mind, so if you're doing this without a DRO, make sure that you take into account any backlash. So always, go past the part and then come back up in the clockwise direction. So you want 932. 932. So there we are, final cut. And there we are. So of course now comes the bandsawing part. I won't show you that. I'll take the part out, deburr it, and bandsaw the chunk off. I shall return. Right, so here I am, back to bandsaw. The part's been bandsawed off. Now what we need to do is to first off ensure that you've got sufficient depth between the top of your vise and your parallel that's less than what your final dimension wants to be. You don't want any chance of machining into the top of your vise, so I've already checked that. Right, now what we need to do is set the and we should be working from the parallel. So what we actually need to do now is got that down tight. Right, pick up the right, got the depth stop on. Right, pick up the parallel surface. I'm using a piece of 4,000 paper there, so we just bring that down and just to put that onto there, and I'll lock my quill again. Set your vertical dial or DRO to again to 0. Now the part needs to be 500 thou thick, so we need to now lower the table down, and you have to compensate for this piece of paper as well. So you can now put the part in. It's get some clearance on there. We'll get there. Put the part in there. See if that will, hopefully that will tighten up. Okay. Right. You can tap it down if need be. Yeah, it depends how. Yeah, that's got it. Right, and now proceed to machine the top away until it reaches a reading of Brett Davies' brain. Yes, sorry about that. The brain went there. Yes, the part needs to be 500 thou thick. We've also got to take into consideration the 4,000 paper that's there. So we only need to get a reading of 496. So what we're doing there is we'll just skim across the top of the top of this part. Milling from the outside, that's less burr. You could end up almost burless final cut. What did we say we wanted? 496. Right, 496. That's 496. Cutting from the outside, so there's practically no burr. And there we have it, a job. Ah, let's move that out of the way so I don't walk into it. Let's take it out, deburr it, and see what the outcome is. Join you again in a moment. Right, so here we are. Let's see what we've achieved. This is the part. Now the Sharpie marker on the top was I put on there before I went out to the bandsaw. So this was our initial top surface, and then we actually milled all round all four edges. Anyway, let's see what the outcome was. So bearing in mind that, you know, we're aiming for standard engineering thingies, you know, plus or minus 5 thou. So let's see how what we needed. Now I needed it to be 1.5 inches long. Let's put that on there and see what we get. And we got, can you make that out, 1.503. So that's within tolerance. We needed it 750 the other way. To make that out, 750. And thickness wise we wanted 500. So what have we got there? We've got 49. Oh no, it's not quite parallel. Okay, I suspect what's happened there was I couldn't actually get access to the part properly when I went to tap it down with the mallet, because the cutter was in the way. That's the trouble working around the camera. Anyway, let's see what we got at that end. We've got 497 at that end, so I mean that's within tolerance, and the other end is 491, so that's out of tolerance. But that's my fault for not ensuring that it was tapped down in the vise properly. So right, so to recap, what have we actually achieved by this? Well, you've only had 2 setups in the vise, the initial one, and then after it was bandsawed. So it's only 2 moves in the vise, and you've got all 6 surfaces machined. So you know, if you had a lot of parts to do, it's certainly going to save you many times of opening and shutting the vise. Because the biggest trouble with that, of course, is you have to be so clean each time. You know, you've opened the vise, you've got to make sure, you know, you haven't got any smooth under the parallels, etc. So you know, that's well worth the effort of doing. So I think what I'll do is I'll just do just a recap on the other part, just in case you've missed the point. Alright, so just to recap the original part, what you had to do is you had to physically measure it first in both directions to see how much to take off. You then had to put it in the mill, clean one surface, rotate it through 90 degrees, clean the other surface to size. You then had to mill the end. You then had to flip the part, mill the other end, and measure it. And what did you end up with? That so that's 2 measurements that you had to do. You had 2 rotations, 2 flips, so that's 4 vise moves, and it was only machined on 4 surfaces. So hope that helps. Let's go inside and conclude this. Join you in a moment. Bye. Oh, so there we are. That was an interesting exercise. I hope you'll find it useful. As I say, as I did explain outside there, you know, you really need, you know, unless you want a lot of exercise, hand hacksaw, you really need a bandsaw to do it that way. Now, you can do it with smaller stock material, but I wouldn't advise you to grip the part in the vise of less than 200 thou, because especially on stock materials like aluminium and copper, because there's always a chance, you know, you've got a higher ratio of the material sticking out the top. You know, there's always a chance that the cutting action, you know, can sort of, you know, squeeze the part out. So yes, you know, I could have made that part out of you know, if I'd had a piece of stock an inch thick, well, yeah, I'd have had to go with that, but I didn't have the inch thick stock. So just bear that in mind. As long as you've got at least 200 thou nipped up in the vise, nice and tight, yeah, just go for it, because I mean, you can soon skim 200 thou off, but I certainly didn't want to machine all that big block away. That's why I went outside and shoved it on a bandsaw. So there we are. Hope you got some useful information out of that. So please subscribe, ring the bell, click the like, send me a comment, and until we meet again in another video, wherever you are in the world, please stay well, safe and happy, and catch you next time. Bye. Where's my hand? There it is. Bye.